The channel was a mirror of steel and foam under the dawn light of August 1944. Waves crashed against the hulls of Allied landing craft, their wakes slicing the water like the paths of invisible blades. Early morning mist clung to the decks, dampening the sounds of engines, footsteps, and the quiet chatter of men whose faces betrayed exhaustion and determination. Somewhere beneath that restless water, miles of pipeline lay coiled like sleeping serpents, hidden from German eyes, waiting to deliver the lifeblood of war: fuel. On shore, the fields of Normandy were scarred from weeks of relentless bombardment. Tanks and trucks churned the mud, their engines belching smoke into the gray sky. Soldiers labored to connect hoses, clamps, and pumps, knowing every hour saved meant a sharper edge for the advancing Allied forces. Engineers marked coordinates and depths, tracing lines across maps with precise, almost obsessive care. They moved with a rhythm dictated by necessity, aware that a single mistake could strand a division, halt an offensive, or reveal the secret under the sea that German officers insisted was impossible. By mid-morning, the first petrol flowed quietly through the undersea pipes. Invisible, unstoppable, and utterly transformative. Operation PLUTO had begun, reshaping the battlefield long before any shot was fired. In the summer of 1944, Europe teetered on a fragile edge. The Allied push from the beaches of Normandy was progressing, but the scale of the invasion demanded an unprecedented logistical effort. Millions of men, thousands of vehicles, and a seemingly endless flow of ammunition and fuel had to cross the English Channel. Every day, the front lines advanced, yet every advance threatened to outpace supply lines. Without fuel, tanks stalled in fields of churned mud. Trucks carrying food and ammunition ground to a halt. Artillery became silent. The success of Operation Overlord depended not only on courage and firepower, but on a hidden network that few outside Allied command fully understood. German intelligence, confident in their own assessments, had consistently underestimated the Allies' capacity for ingenuity. They saw the channel as a barrier, a natural defense, and assumed that supplying a massive invasion force across it would be a months-long ordeal. German officers calculated that any attempt to maintain a rapid advance from Normandy would be limited by traditional methods: convoys of tankers vulnerable to submarines and aircraft. What they did not anticipate was a system that could deliver thousands of tons of fuel every day, silently beneath the waves, connecting England directly to the heart of the French campaign. Behind the beaches, engineers and planners worked in near total secrecy. The pipeline was not a single continuous line, but a combination of flexible hoses and steel tubing, specially designed to withstand tides, storms, and enemy sabotage. Trials had been conducted in the North Sea months earlier, testing the tensile strength, pressure resistance, and underwater anchoring techniques. Every measurement, every calculation, reflected a new kind of warfare, one in which engineers and chemists carried as much weight as soldiers on the front. Simultaneously, on the ground, the logistical networks of the Allies were being overhauled. Fuel depots, tanker parks, and pumping stations were constructed at a pace that rivaled the speed of combat units themselves. Roads and railways were repaired, extended, and reinforced, creating arteries that could sustain the explosive tempo of armored divisions. Coordination between engineers, intelligence officers, and field commanders was essential. Each drop of petrol carried the potential to turn the tide in a localized engagement, whether a hedge-bound skirmish or a full-scale tank battle. The scale of planning was staggering. The pipeline alone stretched more than 200 miles, combining undersea segments, overland conduits, and pumping stations capable of maintaining pressure and flow. Every segment had to account for terrain, tides, soil composition, and the risk of discovery. German reconnaissance had observed troop movements, ship departures, and vehicle convoys, but they were blind to the invisible arteries threading beneath the channel's surface. To them, the idea that Americans could lay such an extensive system was absurd, almost comical, a notion unworthy of serious concern. Yet the Allies pressed forward. For every night spent rolling out flexible pipe along the Channel seabed, thousands of men labored on shore, welding joints, burying sections, and testing pressures. Engineers moved with precision, often under the threat of enemy artillery or air reconnaissance. In ports and along beaches, specialized units managed storage, flow rates, and connections, ensuring that when the first tank rumbled off the beaches, fuel would meet it without delay. Every decision, every meter of pipe, reflected a calculation that had been refined over years of planning, experiments, and wartime improvisation. By mid-July, the framework was complete. German forces, entrenched in defensive positions and expecting the invasion to slow under logistical strain, remained unaware of the transformative network beneath the waves. They prepared for what they thought was inevitable: delays, shortages, and the grinding attrition of a supply-starved opponent. The Allies, in contrast, relied on a new principle of warfare: mobility powered by invisible infrastructure. With Operation PLUTO, supply lines could no longer be targeted by conventional interdiction. The war would increasingly favor those who controlled not just the front lines, but the very flow of energy sustaining them. Beneath the surface of the channel, the pipelines represented more than steel and rubber. They embodied a marriage of technology, strategy, art, and human endurance. The engineers who designed them faced unprecedented challenges. The tides in the channel could reach speeds of over 6 knots. The seabed was uneven and littered with debris from centuries of shipping and war, and winter storms had already torn through experimental lines. Flexible hoses, nicknamed haze for high-altitude inflation steel, were wrapped in protective armor and coated to resist corrosion, while rigid steel tubes, called hamels, were threaded together with precision to maintain pressure over long distances. Every joint, every anchor point, had to account for expansion, contraction, and the violent churn of the sea. Overland, the system continued through France, traversing fields, forests, and small villages. Engineers had to camouflage every section, blend pipelines with existing infrastructure, and coordinate with local resistance networks to prevent discovery. Pumping stations were powered by portable engines, some mounted on trucks, others hidden in barns or converted cellars. Fuel flowed at a rate that defied German expectations, keeping armored divisions advancing at speeds that once would have been unsustainable. German intelligence, still unaware of the full extent of the system, continued to underestimate the Allies' operational range. Their reports cited traditional supply bottlenecks, missing the fact that a silent artery of petroleum now pulsed beneath their defenses. The intelligence effort behind PLUTO was as meticulous as the engineering. Reconnaissance teams monitored tides, currents, and seabed composition, while scientists calculated flow rates, viscosity changes with temperature, and pressure tolerances. Military planners ran simulations, factoring in enemy countermeasures, potential sabotage, and mechanical failures. The result was a system capable of delivering 2,500 tons of fuel per day at its peak, sufficient to supply entire armored corps without interruption. This was not a marginal advantage, it was a decisive one. The secrecy surrounding the project was absolute. Very few in the field understood the full scope of the operation. Soldiers operating pumps on the beaches, engineers diving to inspect lines, and officers coordinating logistics all held only fragments of the whole picture. German forces, in contrast, continued to rely on aerial reconnaissance and human intelligence, neither of which revealed the hidden lifeline beneath the channel. Any interception of convoys or observation of onshore facilities appeared routine. The strategic genius lay in the invisibility of the network itself. Meanwhile, the Allies faced the constant risk of mechanical failure and environmental disruption. Storms could sever hoses, shifting sands could expose steel pipes, and anchors could fail under the strain of strong currents. Contingency plans were extensive. Replacement sections were stockpiled, divers trained for rapid repair, and pumping stations equipped to reroute flow in case of localized damage. Every contingency reflected a single principle: fuel must reach the front uninterrupted, or the speed of the Allied advance would falter. By late August, the system had proved its worth. Tanks surged forward across Normandy and into northern France, their tracks leaving deep ruts in the churned earth. Supplies followed seamlessly, invisible but vital. German officers, still unaware of the pipelines, struggled to anticipate the Allies' capacity for rapid, sustained movement. Where they expected delays and attrition, they encountered relentless momentum. Operation Pluto had transformed the battlefield without a single shot. A demonstration of strategic foresight, engineering mastery, and operational discipline. The technological achievement was matched by the human effort sustaining it. Soldiers and engineers worked long hours in mud, rain, and cold, often under threat of artillery or reconnaissance. Their labor went unnoticed by history for decades, yet it was the lifeblood of the front. Each joint welded, each hose secured, each pumping station activated, represented the intersection of science and warfare, proving that victory often depended as much on innovation as on courage. The first armored units reached the outskirts of Caen under a gray, drizzling sky. Engines hummed in low, constant tones, punctuated by the metallic clatter of tracks against churned mud. Soldiers perched atop Sherman tanks scanned hedgerows and ruined farmhouses, anticipating ambushes that rarely materialized, not because the Germans were unprepared, but because the fuel that should have stalled their advance never ran out. Every tank, every truck, every artillery piece moved as if the battlefield itself had been engineered to anticipate them. The human experience of combat, often defined by sudden scarcity, was here transformed into a relentless, machine-driven momentum. Men reported fewer breakdowns, fewer stalled vehicles, and an unbroken chain of movement that carried them deeper into occupied territory each day. From a tactical perspective, the continuous supply of fuel allowed Allied commanders to implement strategies previously considered impossible. Rapid thrusts by armored spearheads could be maintained over distances that had once required weeks of logistical buildup. The Germans, trained to expect slowing advances, were repeatedly surprised by the tempo of attacks, the sudden emergence of armor in unexpected locations, and the relentless push toward key logistical hubs. The presence of Operation Pluto meant that the tempo of operations was dictated not by available fuel, but by strategic intent. Commanders could exploit gaps, flank defensive positions, and sustain pressure with a fluidity unmatched in prior campaigns. Technology underpinned every movement. The combination of flexible Heiss hoses and rigid Hamel pipes created a network resistant to environmental hazards, able to maintain continuous flow even under stress. Pumping stations calibrated pressure precisely, ensuring that fuel arrived at the required rate without interruption. Engineers monitored every meter of pipeline, accounting for tide, temperature, and terrain, translating complex scientific data into immediate battlefield advantage. Each technical decision, anchor placement, pipe diameter, joint reinforcement, had direct tactical consequences. Without this infrastructure, mechanized divisions would have slowed to the pace of infantry on foot, leaving them vulnerable to counterattacks. Command decisions reflected a new understanding of operational reach. Planners synchronized movements across corps and divisions, integrating Pluto's capabilities into broader strategic objectives. Routes were chosen not only for terrain and enemy presence, but for access to pumping stations and storage depots. Reserves were deployed to reinforce areas with higher consumption, ensuring continuity of movement. In real time, officers coordinated supply and combat operations in a way that blurred the line between engineering and strategy. Every operational order took into account the silent network beneath the channel, allowing planners to exploit mobility as a weapon in its own right. German countermeasures, when attempted, were hampered by incomplete intelligence. Submarine patrols, aerial reconnaissance, and commando raids focused on traditional supply lines. Unaware that thousands of tons of fuel were flowing underwater and across the countryside. Interceptions at ports or along roads had minimal impact. The invisible arteries beneath the sea were untouched. Miscalculations in German assessments meant that Allied advances encountered less resistance than expected. And commanders could concentrate forces at decisive points rather than divert them to protect convoys. The operational surprise of Pluto was not in its secrecy alone, but in its direct impact on the battlefield tempo. Psychological dimensions were subtle but significant. Soldiers experienced a rare sense of continuity, a confidence that vehicles would not stall mid-assault, that tanks would not run dry, that artillery would fire uninterrupted barrages. This reliability reinforced morale, instilling a quiet assurance that the Allies were not just advancing, they were sustained by an invisible force of logistical mastery. In contrast, German troops faced a perception of sudden, inexplicable mobility, encountering armored thrusts without the expectation of imminent fuel shortages. The psychological imbalance amplified the tactical advantage as defenders were forced to react to movements they could not predict or impede. By early September, Allied spearheads were approaching the Seine, pushing German units into hastily prepared defensive positions. The human experience on the battlefield was one of constant motion. Infantry moved alongside armored columns, relying on the steady rhythm of mechanized transport that Pluto enabled. Soldiers described the uncanny reliability of fuel supplies, how vehicles that might have stalled in mud or overextended terrain kept rolling, engines humming like clockwork. In letters and reports, engineers documented hours of grueling labor, securing pipes, monitoring flow, repairing minor ruptures, yet their work remained largely invisible to those at the front. The contrast between the visible chaos of combat and the silent orchestration of logistics defined the human dimension of the campaign. From a tactical and strategic perspective, Pluto reshaped operational planning. Previously, armored divisions had been limited by distance from fuel depots. Offensive operations required careful pacing to avoid overextension. With the pipeline fully operational, planners could extend thrusts deep into enemy-held territory, coordinate multi-pronged assaults, and maintain momentum without waiting for vulnerable tanker convoys. Rapid redeployment of units became feasible, allowing forces to exploit weak points in German defenses. The result was not only a faster advance, but a continuous pressure that German commanders struggled to counter, forcing withdrawals and piecemeal defensive arrangements. Technological and logistical factors reinforced this advantage. The combination of undersea and overland pipelines, pumping stations, and storage depots created a resilient system capable of rerouting fuel as needed. Engineers anticipated blockages, corrosion, and mechanical failures, keeping replacement sections and repair crews at the ready. Even when sections of pipe were damaged, flow could be restored within hours, a feat impossible under traditional convoy methods. This technological foresight ensured operational continuity, allowing divisions to sustain speed and firepower over extended distances with minimal disruption. Command decisions leveraged these capabilities with precision. Corps and divisional officers coordinated supply and combat operations in real time, making movement, deployment, and resupply a seamless process. Orders were issued with confidence that fuel would arrive exactly where and when it was needed. The integration of Pluto into command planning elevated logistical considerations to strategic leverage. Mobility itself became a decisive weapon. German officers, constrained by expectations of delayed supply, were repeatedly outmaneuvered, their plans rendered reactive rather than proactive. Enemy countermeasures remained largely ineffective. German intelligence, unable to detect the pipeline network, concentrated on conventional interdiction, attacking ports, harassing convoys, and laying mines along roadways. These efforts had minimal impact on the flow of fuel beneath the sea and across liberated territory. The Allies' ability to maintain uninterrupted supply lines neutralized anticipated disruptions, giving frontline commanders freedom to press attacks without concern for overextension. This operational resilience compounded the element of surprise, increasing the effectiveness of each maneuver. Psychologically, the effect on German troops was profound. The speed and reach of Allied advances appeared disproportionate to their understanding of supply capabilities. Soldiers reported armored columns appearing where no fuel could reasonably reach, reinforcing a sense of inevitability in the Allied advance. For Allied troops, the confidence generated by reliable logistics translated into aggressive, decisive action. The combination of technical mastery, operational planning, and human endurance created a force that moved not merely with strength, but with calculated certainty. By the first week of September 1944, the Allied advance reached the outskirts of the Seine, where German defenses stiffened in towns, river crossings, and elevated positions. Dawn broke with a muted light, mist clinging to the fields and hedgerows as Sherman tanks rumbled forward. Artillery fired intermittently, smoke curling upward in gray spirals, mingling with the chill morning fog. Engineers monitored pumping stations inland, watching gauges that confirmed uninterrupted flow. Every tank that rolled off the bridge into French territory carried more than men and steel. It carried fuel that had traversed more than 100 miles of seabed and overland pipe, silently enabling the offensive. In the villages along the Seine, the human experience was immediate and chaotic. Civilians emerged from shattered homes, watching armored columns surge past, while infantry advanced on narrow roads flanked by bombed-out buildings. The monotony of waiting, of supply shortages that had crippled earlier campaigns, was replaced by constant motion. Soldiers reported engines that never faltered, trucks that never ran dry, artillery that maintained sustained fire. Tangible proof that logistics had become as decisive as any battlefield maneuver. Every human action was amplified by the reliability of unseen engineering, a force multiplier that German observers could neither predict nor counter. Tactically, the continuous fuel supply allowed commanders to execute maneuvers that German officers had deemed impossible. Armored spearheads bypassed strong points, forcing enemy units into retreat or encirclement. Bridges, roads, and river crossings became arteries for relentless movement rather than bottlenecks. Corps commanders coordinated simultaneous assaults across multiple axes, confident that vehicles could advance at full capacity without fear of immobilization. The strategic calculus shifted. Operational reach no longer hinged on convoy security, and speed became a weapon in itself. Technologically, the operation demonstrated unprecedented integration of human skill and mechanical reliability. Pumping stations maintained precise pressures, ensuring fuel arrived at correct flow rates across distances that exceeded any prior campaign. Divers and engineers repaired damaged hoses under tension and tidal currents, restoring sections in hours. Flexible and rigid pipelines were combined to optimize resilience and efficiency. Each innovation was tested against the harshest conditions of sea, land, and weather, and each succeeded, converting raw ingenuity into battlefield advantage. Command decisions leveraged these advantages ruthlessly. Generals and corps officers issued orders with full knowledge that supply would be uninterrupted. Tank regiments advanced in tight formation, artillery moved without pause, and infantry coordinated maneuvers with mechanized units across extended fronts. German officers, expecting delays and shortages, found themselves consistently outmaneuvered. Defensive positions that should have held became untenable under the sustained, rapid pressure made possible by a network they could neither see nor anticipate. German countermeasures faltered at every turn. Reconnaissance aircraft observed columns but misjudged their operational endurance. Attacks on ports, roadways, and fuel depots failed to impede the invisible lifeline beneath the channel. Mines and ambushes could not sever the undersea arteries. Each attempt to slow the Allied advance was met with unbroken mobility, reinforcing the perception of inexorable force. The psychological impact on German troops was immediate. Bewilderment at speed, disorientation at depth of advance, and erosion of confidence in defensive plans. By midday, the Seine crossings had become a corridor of relentless motion. Sherman tanks, Cromwell and Churchill variants, rumbled across pontoon bridges, their tracks carving deep grooves into muddy riverbanks. Fuel flowed continuously through the undersea and overland pipelines, unseen but indispensable, maintaining pressure on armored divisions and artillery units alike. Engineers patrolled pumping stations, inspecting gauges and joints, while soldiers moved in synchronized rhythm, aware that any interruption could slow the advance. Yet the system held, flawless under the stress of war, defying both natural forces and enemy anticipation. German defensive positions crumbled under this sustained pressure. Counterattacks, hastily organized, failed to stall columns that seemed to appear out of nowhere. Engines humming steadily, thanks to the hidden pipeline. Artillery units were neutralized or bypassed. Villages once expected to delay the Allied push were overrun before resistance could consolidate. Commanders on the German side recorded confusion in their logs, noting that mobility far exceeded expectations and that supply lines appeared impervious to interdiction. Pluto, invisible beneath the sea and across liberated territory, had become a force multiplier the enemy could neither detect nor disrupt. Tactically, the Allies exploited the continuous supply with precision. Flanking maneuvers enveloped German units, armored regiments struck at weak points, and infantry coordinated assaults with artillery barrages timed to the exact rate of fuel-supported mechanized movement. Bridges and narrow roads, previously potential choke points, became conduits for unrelenting momentum. Commanders orchestrated these operations with confidence, knowing the logistical backbone was secure. This operational fluidity transformed every advance into a compounding pressure on German defenses, accelerating collapse along multiple sectors simultaneously. Technological and logistical factors were tested to their limits. Storm-swollen rivers threatened pump operations. Minor ruptures were repaired within hours. Flexible hoses adjusted to tidal shifts, while rigid steel pipes maintained structural integrity. Replacement sections were deployed preemptively. Engineers worked in rotating shifts to ensure constant vigilance, and gauges were monitored around the clock. The combination of foresight, design, and human endurance ensured uninterrupted flow, turning fuel itself into a decisive weapon on the battlefield. Psychologically, the impact was profound. Allied soldiers felt an unprecedented confidence. Vehicles never faltered, artillery never paused, and armored units advanced without hesitation. German troops, confronted with relentless and inexplicable mobility, were demoralized. Units that should have delayed the advance were bypassed. Defenses collapsed under pressure they could not anticipate. The speed and certainty of movement created a sense of inevitability, reinforcing the strategic advantage gained not from firepower alone, but from innovation, planning, and logistical mastery. By late afternoon, the Seine crossings were secured, and the front had shifted decisively. Pluto had transformed a logistical challenge into a strategic weapon, allowing the Allies to maintain operational tempo while denying the Germans any opportunity to regroup. The invisible arteries of fuel beneath the channel had reshaped the battlefield, turning conventional expectations of supply and mobility on their head. The advance continued, sustained not just by men and steel, but by ingenuity, engineering, and a vision of warfare that redefined the limits of operational reach. The immediate consequences of Operation PLUTO were stark and tangible. Within days of the Seine crossings, Allied armored divisions had penetrated deeper into northern France than German planners had anticipated, cutting off retreating units and capturing key logistical hubs. Casualty reports noted fewer mechanical failures among vehicles, reducing delays and exposure to counterattacks. Tank regiments, once slowed by fuel shortages in prior campaigns, moved with unprecedented consistency. Engineers documented minor ruptures and maintenance incidents, but the overall system functioned without catastrophic failure, a logistical triumph that directly translated into battlefield effectiveness. For German forces, the psychological effect was immediate. Officers' reports conveyed bewilderment and frustration. Columns appeared in locations deemed unreachable. Armored thrusts maintained a pace that outstripped any reasonable expectation, and defensive positions intended to delay the Allies were rendered ineffective. The failure to intercept or even detect the undersea pipelines created a sense of vulnerability, eroding confidence in operational planning. Units forced into retreat often abandoned equipment and positions, not solely due to combat losses, but because the speed and reach of the advance overwhelmed their capacity to respond. On the human level, soldiers in the field experienced a rare sense of operational continuity. Infantry advanced alongside tanks, artillery maintained sustained barrages, and logistical units kept pace without interruption. Morale benefited from the reliability of machinery and mobility. Reports from divisional headquarters indicated that commanders were able to plan complex maneuvers without concern for fuel shortages, allowing a focus on tactical objectives rather than logistical contingency. The psychological weight of uninterrupted supply subtly amplified the combat effectiveness of every unit in the field. Strategically, the success of Pluto reinforced the Allied doctrine that operational mobility could be a decisive weapon. Supply lines no longer dictated the pace of operations. Engineering and planning could extend the reach of forces far beyond traditional limitations. German forces, constrained by conventional expectations, were repeatedly forced into reactive strategies, defending positions that were no longer tactically advantageous. The interplay between technology, logistics, and strategy demonstrated a new paradigm. The front lines were no longer determined solely by combat, but by the invisible infrastructure that sustained it. The long-term consequences of Operation Pluto extended far beyond the immediate advance through northern France. The pipeline proved that sustained mechanized operations could be maintained over vast distances without reliance on vulnerable surface convoys. Military planners across the Allied forces incorporated these lessons into future campaigns, understanding that engineering ingenuity could multiply combat power as effectively as additional troops or weaponry. The success of Pluto became a case study in operational logistics, influencing planning for operations in Western Europe and later theaters of war. German analysis, conducted after the liberation of France, acknowledged the strategic surprise and operational efficiency of the pipeline. Intelligence reports, initially dismissive, documented the scale, complexity, and resilience of the undersea and overland system. These reports underscored the Allies' ability to integrate engineering, logistics, and tactical planning into a coherent operational advantage. In subsequent months, German forces faced the consequences of underestimating infrastructure-based warfare, with delayed responses and misallocated resources directly tied to the unseen lifeline that had powered the advance. Technologically, Pluto set new standards for underwater and overland pipeline construction. Flexible hoses, pressure-resistant steel tubing, and portable pumping stations were studied, replicated, and adapted for post-war civilian and military applications. Engineers and military strategists recognized that the capability to deliver fuel rapidly and securely could determine the outcome of entire campaigns, reshaping doctrine for mechanized warfare in the 20th century. The project became a reference point for innovation under wartime pressure, demonstrating how engineering could redefine operational possibilities. Human legacy was equally profound. Thousands of engineers, technicians, and soldiers contributed to the operation under extreme conditions, often in secrecy. Their work, largely invisible to the public for decades, demonstrated the critical intersection of skill, endurance, and planning. Letters, reports, and post-war testimonies emphasized that the success of Pluto depended on meticulous attention to detail and coordination at every level. The operation illustrated that victory was not only a matter of courage on the battlefield, but also of invisible networks, foresight, and the quiet labor that sustained mechanized forces. Pluto's impact continued to resonate in Allied campaigns through the final months of 1944. Armored thrusts and rapid advances in the Low Countries, fueled in part by lessons learned from pipeline logistics, maintained pressure on German forces. The operation's success undermined the assumption that natural obstacles or supply constraints would slow mechanized offensives. by demonstrating the strategic power of invisible, reliable infrastructure. Pluto reshaped both Allied doctrine and the German understanding of modern warfare, leaving a legacy that extended well beyond the Normandy beaches. By the close of 1944, the success of Operation Pluto had become a quiet testament to the transformative power of engineering in modern warfare. The fuel that flowed beneath the channel was invisible, yet it reshaped the battlefield, accelerated advances, and sustained operations that might otherwise have faltered. It proved that victory relied not solely on firepower or numbers, but on foresight, precision, and the seamless integration of technology and human labor. The pipelines themselves, unheralded at the time, symbolized a shift in the nature of warfare. Logistics, once a supporting role, became decisive. The advance through France illustrated how innovation could outpace enemy expectations, turning infrastructure into a weapon as potent as tanks or artillery. German forces, confronted with movement they could neither see nor impede, experienced firsthand the strategic consequences of underestimating the invisible networks that powered the Allied war effort. For the men who built, maintained, and operated Pluto, the legacy was one of quiet endurance and meticulous skill. They labored in mud, under fire, and in secrecy. Yet their contribution sustained entire armies and changed the course of the campaign. Operation Pluto stands as a reminder that in war, as in peace, the unseen often wields the greatest power, and that human ingenuity, careful, persistent, and precise, can redefine the very limits of possibility.